Welcome to Alaska Weather, a production of Alaska Public Media and the National Weather Service, Alaska Region. Produced and broadcast daily from the studios of KAKM, Alaska Weather provides complete forecasts, public, marine, and aviation for all of Alaska. Alaska Weather is made possible by the following sponsors.
Support comes from the University of Alaska College Savings Plan, helping you and your child save for college every step of the way, from diapers to diploma. More information at uacollegesavings.com.
The National Weather Service.
Seven sisters, a double cluster, and more. Hey there, stargazers. I'm James Albury, director of the Kika Silva Pla Planetarium in Gainesville, Florida.
And I'm Dehne Regas, astronomer for the Cincinnati Observatory.
It's that time of year when you can see one of the most famous star clusters, the Pleiades, better known as the Seven Sisters.
But do you know that there are two more star clusters, twin clusters so to speak, just a short visual distance away?
And have you ever wondered what was the farthest thing you can see with the naked eye? Let's show you. Okay, we've got our skies set up for next week around 9 p.m. And if you look above the eastern horizon, you'll see what looks like an exquisite, tiny little dipper-shaped cluster of stars, the Seven Sisters.
Now, most people only see 6 stars here with the naked eye, but really good eyes under ideal conditions can see 7 or more. With binoculars, you could see several dozen. There are really over 250 stars here, all much larger and hotter than our own sun.
And cosmically speaking, they're not very distant, only about 400 light years away, which means that we see the Pleiades as they existed 400 years ago, about the same time Galileo first trained a telescope on them.
Now, to find the twin clusters, look directly above the North Star, where you will see 5 stars that trace out the M-shaped constellation of Cassiopeia the Queen. Then to the right of Cassiopeia, you'll see 2 faint, fuzzy Q-tip-like objects. And if you are far away from city lights, where it's good and dark out, you will notice that they are embedded in the river of light we call the Milky Way. Now, these 2 dim, fuzzy balls of light are called the double cluster Perseus. And although each has about 100 more stars than the Pleiades, they're not as bright to us because they are so much farther away. In fact, unlike the Pleiades' 400 light years distance, they are a grand 7,000 light years away.
Now, let's get back to my question about the farthest thing that's visible with the naked eye. Let's start with the moon. It's very easy to see, and it's almost 250,000 miles away. Let's step it up a notch and take a look at Venus. Next week, Venus will be about 100 million miles away. Still easily seen with the naked eye. Let's go another step and look at Jupiter next week. The king of the planets is about 600 million miles away and still easily seen with the unaided eye.
We're approaching the answer, but we have a long way to go yet. We can't describe how far we can see in terms of miles alone. We have to shift to light years, with each light year being about 6 trillion miles. Quite a jump, eh? We're not talking about just a few light years either. We're talking about over 2 million light years. But what could be so bright that we can see it with our unaided eyes at such a distance?
To answer that, let's first find Pegasus the horse. If we draw lines between 4 not-so-bright stars, we would trace a great celestial square. And with a few other stars, and a little imagination, we could connect stars to this square to make a long neck. The bright star Enif can make our horse's nose.
A few dim stars can form 2 short front legs, and some others can stand in for 2 hind legs. Now, most people call the hind legs something else, Andromeda the princess. And maybe the name Andromeda will give you a galactic hint as to what is the farthest thing you could see with the naked eye.
It's difficult to find, and you must have clear, dark, moonless skies like next week. But if you squint, you may see a dim, fuzzy patch of light. It's called M31, the Great Galaxy of Andromeda, which, through a telescope, reveals itself to be a gigantic family of 1 trillion stars that's over 2.5 million light years away.
So we have 3 star clusters and 1 galaxy that are visible in a fairly small chunk of the night sky next week. To find them, you must keep looking up.
Technology. It's the rhythm of our everyday life. We're more dependent on satellite and communication systems than at any other time in history. Disruptions can affect our economy and even our safety. To prepare for the effects of such events and minimize impacts, we need to look outside our atmosphere, some 93 million miles away, at a star we call the Sun. It's our main energy source. It warms the Earth and grows our food. While the Sun and the space between may seem pleasant from our perspective, it's anything but peaceful. At its surface exists a chaotic state of eruptions and radiation. And unlike Vegas, what happens at the Sun doesn't stay at the Sun.
Space weather is essentially emissions from the Sun, radiation, magnetic field that erupts from the solar surface, pumped out into space, sometimes right towards Earth. When it impacts the Earth, it impacts our technology. That's what we call space weather.
These solar events and their effects at Earth can disrupt systems we take for granted. From causing blackouts to the power grid, to delaying offshore drilling operations due to inaccurate GPS data. Interference with communication systems can force air traffic to reroute and impact rescue response and coordination. Outside our atmosphere, solar radiation can harm astronauts and the systems they depend on. The good news is that these eruptions can be detected early. Forecasters at the NOAA Space Weather Prediction Center in Boulder, Colorado, have their eyes on the Sun at all times.
The Space Weather Prediction Center is part of the National Weather Service and is very much like a normal weather forecast office. We're here 24 hours a day, 7 days a week. We're looking at data, we're looking at imagery, we're looking at model outputs. As conditions develop, we put out alerts, warnings, and watches of imminent activity to our customers so they can take action.
In many ways, forecasting space weather is a lot like forecasting hurricanes. Those who rely on space weather forecasts, like electric power grid managers, are informed early on and can begin taking protective action.
When we see an eruption on the Sun, space weather forecasters will issue a watch. This is much like a hurricane watch. When a hurricane sits offshore of Miami, for example, perhaps 48 hours out, we too can see way in advance that something may be coming towards the Earth.
As the storm moves toward us, it hits a monitoring spacecraft orbiting 1 million miles away from Earth.
It's kind of our buoy sitting out there offshore, and that hurricane, about 30, 45 minutes before it makes landfall, we'll get the measurements from the buoy. That's what this spacecraft does for us. That big eruption that left the Sun hits the spacecraft. Now we've got the measurements of exactly what's going to impact us here on Earth, and we issue the warnings to give the power grid a heads up that the storm is now imminent. An interesting element to this whole process is that when the forecasters issue the alert, the power grid receives the alert, takes the necessary actions to protect the grid, the average citizen never knows anything ever happened.
The number of customers who rely on space weather information continues to grow. As our reliance on technology increases, so will our need for constant monitoring of the sun.
In recent years, the GPS receiver has been one of the most useful tools for professional pilots, drivers, and seafarers. These receivers use geospatial data to identify geographic locations and characteristics of natural and man-made features on the Earth.
These receivers are also being used by hikers, golfers, and fishermen for recreation purposes. However, many people who use this technology still don't know exactly how it works.
Our Johnny Alonso finds out how this complex system helps keep many of us on track and on schedule.
Trying to figure out where you are and where you're going has always been a challenge. Navigation and positioning are crucial to so many activities, and yet the process has not always been easy. Thankfully, the days of navigating by celestial means or landmarks are long gone since the introduction of GPS, or the Global Positioning System. So what is GPS? For some answers, I spoke with Dr. Kevin Dutton at NASA Langley to find out how it works.
GPS stands for the Global Positioning System. And like the name suggests, it's a system to find your location anywhere on the Earth or near the Earth's surface. And the way it does that is by using radio frequency broadcasts from orbiting satellites.
Can you tell me why GPS was originally developed?
It was developed by the Defense Department to meet all of their navigational needs. For example, aircraft and ships at sea. And now even individual soldiers carry little receivers like this in the field to find out where they are.
The Global Positioning System consists of a constellation of 24 satellites and their ground stations working together. GPS uses these man-made stars as reference points to calculate positions accurate to a matter of meters, and in some cases centimeters. As long as you have a GPS receiver and a clear view of the sky and a map, you'll never be lost again. Today, GPS is finding its way into cars, boats, planes, construction equipment, farm machinery, even laptop computers. So how does the system work?
Let's say you're backpacking and you have a receiver with you. You're going to turn on that receiver. Now the GPS satellites are constantly broadcasting a signal, all 24 of them, but above you at any one time there's only 12 available, and then the other 12 are on the other side of the Earth.
Okay.
So your receiver is going to listen and try to find at least 4 of these satellites directly above you. And then it's going to determine a range to each satellite, and it's going to use those ranges and the known locations of the satellites, and it's going to do some mathematical calculations and a process called trilateration, and it's going to figure out where that GPS receiver is. That'll also give you altitude, and it'll give you speed and the direction that you're traveling in.
A standard GPS receiver will not only place you on a map at any particular location, but will also trace your path across a map as you move. If you leave your receiver on, it can stay in constant communication with GPS satellites to see how your location is changing. With this information and its built-in clock, the receiver can give you several pieces of valuable information like how far you've traveled, how long you've been traveling, your current speed and your average speed. Also, the estimated time of arrival at your destination if you maintain your current speed.
There's a lot of uses that they hadn't really thought about when they developed the system. For example, later on it was discovered that if you put multiple antennas on a vehicle, like an aircraft for instance, you could actually get attitude. You could figure out its orientation and whether it was rolling or pitching or yawing. Other things that they didn't realize it could really do were, for instance, seismologists use it for earthquake detection and to find out when tectonic plates are actually shifting apart. It's that good.
Something else.
Yeah, very interesting.
Sure. So that's how it works. So the next time you want to know where you are or where you're going, don't reach for a map. Reach for your GPS. Now, which button is it here to press for a date for tonight's gathering at 3?
That's all for this edition of NASA's Destination Tomorrow. Thanks for joining us. I'm Steele McGonigal.
And I'm Kara O'Brien. For all of us here at NASA, we'll see you next time.
Welcome to Alaska Weather. I'm meteorologist Percy Dehne. This is your weather for December 1st, 2016. Winter is definitely here. We have plenty of hazards tonight. We have a snow advisory for the upper and middle Ottenweller Valley, and also we have the continued high wind warning that's for the south and south and central and southern the inner canals with strong southerly winds gusting there. Also, we have a blowing snow and snow advisory for the Kodiak region. Check your local times for all these advisories and warnings, as well as we have a high wind warning for Alaska Peninsula, including Cold Bay and Sand Point. Again, check your local weather station there. Putting this in the satellite loop, here's a strong occluded low pressure system that's moving up towards Kodiak, and that's a nice swath of clouds here that's going to be affecting Kodiak with bringing the moisture in there for the blowing snow and snow. And the northerly flow here, as you can see to the north, that continues to bring a northerly cold air into the central and lower southwest territory, as well as in Kodiak. For the southwest, you have that strong swath of moisture that's pushing in. That'll continue to bring strong southerly winds in here and continue warm temperatures. So that's why they have that strong wind advisory out. Actually, wind warning. Anyway, the next low pressure system is sitting over this western Aleutians, and that's in the western Bering, as you can see, is pushing through this cyclonic flow. Nice swath of moisture with that low pressure system. Otherwise, the northerly flow will continue to bring scattered snow showers throughout the Chukchi Sea, extending down into the to St. Paul region. And put it into motion, as you can see, the northerly flow, cooler temperatures. You have this continued cloud cover extending all the way down into the central Aleutians towards Dutch. Today's weather, here you have a stationary front extending through the Anchorage Bowl, extending up along the Alaska range. Again, snow occurring in Valdez area northward through the Copper River Basin. Then through the Alaska range, you have scattered snow showers. So this is providing plenty of snow conditions there for the upper Ottenweller and Fairbanks region. And here's this strong occluded front that's going to be pushing up. There's a little break in the action right now, but some light rain occurring today from Yakutat down to Sitka. Otherwise, the western Aleutians, here's that cold front, low pressure system. That's pretty weak, but it is producing some scattered snow showers with that. And then that weak low pressure system that's sitting in the northern Bering, producing some scattered snow showers with that. For tonight's weather forecast, again, the strong occluded low pressure system moves up this 964 millibar low, and that's a occluded front extending across the southeast panhandle. Again, you're going to have a wintry mix and snow farther inland, blowing snow conditions, and that's just going to push over and move westward into the Alaska range and upper Ottenweller region and middle Ottenweller. Otherwise, out west on the western Bering, you have that low pressure system that's gradually starting to move eastward and starting to fill and start to dissipate. It'll continue to produce scattered snow showers, as well as along the chain. You have the northwesterly flow that's going to produce scattered snow showers along the eastern Aleutians. And along the Arctic coastline, northwest coastline, you have that low pressure system that's kicking off some scattered snow showers along the Brooks Range and northward. Friday's forecast is occluded low pressure system. It will just start to dissipate, but you'll have, as this front pushes through, a chance for some isolated thunderstorms. Otherwise, you're going to have a wintry mix as you go farther north along the northern coastal communities. And in the Anchorage Bowl, Copper River Basin, Alaska Range, again, this weak stationary front, you're going to have plenty of snow in this region, producing tight gradient on the back side of it with producing blowing snow conditions. Farther north, you have a weak trough pushing through the Barrel region, and they'll kick off some scattered showers, as well as some scattered showers through the northern Bering and the lower Chukchi Sea. Otherwise, that weak cold front with that low pressure system sitting in the central Bering will continue to dissipate, and it'll still produce some scattered snow showers in that region. Otherwise, the strong next 963 millibars low that's dropping off the Kamchatka Peninsula will produce some strong southwesterly push through the western Berings with wintry mix in those conditions. Saturday's forecast, the cooler low pressure system is filling and starting to dissipate. Onshore flow, so continued scattered snow showers, plenty of cool air here along the southeast panhandle, and we'll have blowing snow conditions throughout the Alaska range and extended up into the Fairbanks region. And farther north, you have high pressure dominating over the Brooks Range, North Slope area. You will have some light scattered showers in that region. Otherwise, that cooler front pushes more into the central Bering. With that continued wintry mix, on the backside, you'll have continued weak lows that'll continue to fill. Otherwise, again, wintry mix with those systems as they push through. Temperatures as of noon today, you can see the coolest temperatures were again farther north through the central interior. Otherwise, you had Cordova at 37, Valdez at 32. The southeast panhandle had the warmest temperatures, 47 at Cloak, 42 at Sitka. And then farther north, you had 12 at Barrow, 20 at Dead Horse. Through the northwest coastline, you had -3 at Wainwright and 10 at Point Hope, 19 at Tin City. Along the Aleutian Chains, again, you had 34 at Sandpoint, 27 at Cold Bay, 32 at Dutch, 28 at St. Paul, 33 coming in at Shemya along the western Aleutians. Tonight's low temperatures, again, the coolest temperatures are going to be farther north, and they'll start filtering down through the lower Kuskokwim Valley into the Southwest Territory. The warmest temperatures, again, with the low pressure system that's starting to move into the northern Bering, northern Gulf, that is. That's why you have modified temperatures here, a little warmer. The southeast will continue the strong southwesterly push of warm air. You're going to have low temperatures in the mid to lower 40s for the southeast panhandle. Tomorrow's high temperatures, again, a little warmer farther north, but not much. Still that continued cooler air and northerly flow that bringing the Arctic air into the region, and it's making it all the way down into the almost into the Bristol Bay region. Otherwise, the Anchorage Bowl is going to be in the mid-teens. The next occluded low pressure system that's pushing through the western Aleutians, you're going to have modified temperatures. You can see they're going to have 39 at Shemya and 35 at St. Paul. The southeast panhandle continued southwesterly push. There's plenty of cloud cover, 47 being the high there at Cloak. Tomorrow's flying weather in the morning, again, worse conditions up here along the Brooks Range, extending through the Bering Strait, IFR to marginal VFR conditions, as well as all in the eastern Brooks Range. The southeast panhandle will have the worst conditions, again, with that onshore push, with that system pushing through with that frontal, just sitting off the southeast panhandle coastline. By tomorrow afternoon, again, the worst conditions as you can get the continued weak front pushing in this area. Otherwise, over here, that front pushes on and it streams moisture all the way over into those areas where we had talked about Middle Tanaval and Upper Tanaval with snow advisories in those regions and extending down into the Copper River Basin. Otherwise, marginal VFR in the Gulf. And the Bering are pretty much marginal VFR conditions, and with the next system pushing in, you're going to have lower conditions there near Shemya. Tomorrow's patches, AKwx, VFR to IFR, Adigan, marginal VFR to IFR, Merrill and Lake Clark, VFR, Rainy, VFR, marginal VFR, Windy, IFR, marginal VFR, Isabel, marginal VFR, IFR, and then Mataska, IFR to marginal VFR, and then Tanita, MVFR to VFR, and then Portage, MVFR, Chillicook, White, IFR. And tomorrow's freezing levels, again, with that next front coming in and that cooler air, you're starting to modify the freezing level at the surface, starting to push up a little bit in the central bearing. Otherwise, that cooler air that's pushing down from the north, the northerly flow, is pushing the surface all the way past the eastern Aleutians. With this high pressure system, well, actually this strong southwesterly push, you have higher freezing levels in the southeast panhandle as you extend southward of the Queen Charlotte Islands, that is. And tomorrow's icing, again, above light to occasional moderate up here through the northern Bering, and then with a system coming across the southeast panhandle and extending over into the Alaska range, you're going to have above 2,000 for light, occasional moderate. And then with the next system coming through the western Aleutians, above 2,000 light, occasional moderate icing. Tomorrow's jet stream, northerly push 140, then it's southwesterly at 90, and then it digs down to northerly push 120 knots, and then transitions southwesterly to 190, strong southwesterly push into the southeast panhandle. And we have a southerly push of a 70 knot jet going through the eastern Berks Range. Tomorrow's 9,000 foot winds. The weak cyclonic flow into central Bering, always northwesterly flow, 15, increasing to 40 knots over the eastern Aleutians. You have that strong cooler low pressure system moving into southeast panhandle, so it's 55 to 40 knots pushing through the Queen Charlotte region. And on the backside of the system starts weakening up to northerly at 10 knots, northeast 15 going through the eastern Brooks Range. And then tomorrow's 3,000 foot winds, strong grading here with the next system, southwesterly push 55, 45 knots there, starts to build, and then the ridge positioned over the central Bering, northwesterly flow as you get into the eastern Bering, 20, 35 knots over the eastern chain. And then that occluded stack low pressure system, again over the southeast panhandle. Strongest winds are just south of the Dixon entrance, or over the Dixon entrance southward, southwesterly 50 knots. Tomorrow's icing, tomorrow turbulence below 4,000, light to occasional moderate, pretty much all over the lower Kuskokwim Valley, the Alaska Peninsula, Alaska Range, extending over the Anchorage Bowl, and then below 4,000 feet over the southeast panhandle, and some isolated thunderstorms.
These forecasts are to be used for planning purposes only. Call 1-800-WX-BRIEF for a formal pre-flight briefing. Always file a flight plan before you go flying. The U.S. Coast Guard Auxiliary urges you to leave a float plan with a friend or the harbor master before you go boating. Alaska Weather is made possible by the following sponsors.
The National Weather Service.
Alyeska Pipeline Service Company, sustaining Alaska's pipeline and its operations today and into the future.